Well, welcome to science, you guys. We're going to start with lesson 1.5, investigating evaporation and freezing. We are only going to be doing parts 1 through 4. So in the warm-up, if you hop into the warm-up, it is going to ask you about the article set that you read last class in 1.4. Um, in the Weird Water article set, the author uses the phrase greater freedom of movement. What do you think she means by this? Use clues from the diagram and the text below to determine what this phrase means. After you've written your response, share your ideas with your group. Just discuss it with your group. You can pause this so that you can answer your warm-up question. So right below this on your warm-up, it also asks you to read a third paragraph before you do your response. If you didn't read that third paragraph, pause now so you can go back and do that. Okay, we're going to go on to activity 2, which is reading about molecular movement. So in the previous lesson, you read the Weird Water Events article set. So we are going to look at a few vocabulary words, and hopefully you remember that article. If you need to go back and look at that Weird Water Events article, you're welcome to do that. You saw it in your warm-up today. So, freedom of movement. Freedom of movement means the way the molecules in a substance move around relative to each other. Is that what you wrote on your warm-up? All right, so remember, we are investigating this question. What happens to the molecules of a substance when it changes phase? So there are 3 claims right now that we have. We have that molecules in a substance disappear or no longer exist when a substance changes its phase. We also have molecules in a substance move differently when a substance changes phase. Or claim 3, molecules in a substance change into a new kind of molecule during a phase change. So these are the same claims, but they're really stated differently. These claims focus on on explaining how molecular behavior can affect the macro appearance of a substance. So today you're going to read the introduction of the Weird Water Events article set. To continue investigating the molecular scale, you'll look for evidence that supports or refutes your claim. In order to evaluate the claims, you're going to complete the table. So this is on screen 2. So if you look at the bottom of activity 2, you'll see 2 little numbers, a 1 and a 2. This is actually card 2, and I'll show you that on Amplify. So as you can see, I flipped over to Amplify so you can see. This is just the vocab term we went over. So you go over to number 2, and here's where you read and annotate the introduction to the Weird Water Events article. Also, make sure you review the diagram that's here too, and review your notes about the molecular scale from 1.3. You may want to copy those and paste those into the column below this after you have read it, and you're going to just, like I said, refer back to 1.3 to help you with answering these questions if you need to. So we're going to go on to, and this is actually activity 2. I already showed this part to you. We're going to move on to the next part of it. So what I want you to do is discuss the evidence you found and recorded with your group members and compare your completed tables. So you guys have any differences? Are they the same? What do you notice about your articles? Make sure that you share that with your partners that you are working with and have a discussion about it. Okay, we're going to move on to activity 3, reasoning about freedom of movement. So you now have some evidence from the text and the sim. Which claim do you think is best supported by the evidence? So your evidence should help you consider the 3 claims and what's happening on the molecular scale to make that phase change. So once you've decided which claim that you are best supporting, you can talk about that with your group as well and discuss it and come to an agreement. Next, we're going to use the reasoning tool to begin constructing our argument about what happens to the molecules of a substance when the phase changes. We'll review how to use the tool using claim 1 as an example. So if you look at your reasoning tool, and I'm going to flip back to Amplify for a second so you can see it. So this is on part 3. This is an Amplify, and it is your reasoning tool, which is right here in front of us. So what they're doing is they're just using the previous claims that you completed in the sim to help us with textual evidence and discussing it with our partners. And this table is actually completed for table or claims 2 and 3. So if you look here, they took a quote from one of the articles and said, no matter what the phase of water the water is in, the molecules stay the same. They just move differently. So this matters because, so how does this evidence support the claim or refute the claim? So this is our answer to that question. If the water molecules stay the same, they cannot disappear when water changes phase. So therefore, we have to refute claim 1 because, like the article said, they just move differently. And also down here, another piece of evidence we have is from the sim. So after removing the heat, the molecules' freedom of movement changed. You saw that in the sim. The molecules went from moving around each other to moving in place. So in the sim, the movement of the molecules changed, but the molecules didn't disappear. So that's my reason why this claim is refuted. So what you're going to do is go over to part 2. And in part 2, you're going to choose which claim you agree with. Okay. And then you're going to explain the reason why you chose this that at this point. Why are you choosing this specific one? So pause the video here so you can answer that question. I also wanted to show you guys this scientific argument tool. So we always have a question about the world and we come up with a claim, just a proposed way to answer how that happens in the natural world. We come up with the reason why we think that's true, and then we have to back it up with evidence. So we need to go and find things that support or refute or go against the claim. So a couple of key concepts we should know at this point. First, we're going to revise this key concept. This was key concept number 1, but we're going to change it a little. So a solid keeps its shape. Well, it keeps its shape because its molecules only move in place, not around each other. We also know that a gas doesn't have a visible shape, and here's the revision for this, because its molecules can move away from each other. The third key concept is a liquid can flow because its molecules move around and not away from each other. So these are your 3 takeaways from this part of the lesson that you should understand by the time the lesson is over. If you don't remember, you can review these. Just go back in the video and review them. And we're going to move on to part 4. So if you have not finished part 3, pause it now. Part 4, modeling a phase change. So you've used reasoning to determine that molecules in a substance move differently when a substance changes phase. You need to apply this idea to Titan's problem before you can make your final argument for Dr. Flores at the agency or the Universal Space Agency. You're going to use the phase change modeling tool to illustrate your ideas about the phase change and molecules. Today you're going to practice using that tool to explain an everyday phase change. In the next lesson, you will model the possible phase change on Titan. So as you saw in an earlier video, we showed you about a melting ice pop. We're going to work together to model this phase change. Let's watch that video again. So now you're going to follow along to complete the model showing what happens to the ice pop. So we're going to hop into activity 4. So if you'll hop into activity 4, as you can see, I hop back over to amplify. So your goal is to show how the ice pop and the molecules it is made of are different before and after it melts. You're going to click this right here and open up the sim or the modeling tool. So there are instructions at the top right here if you need them. You can review them anytime. You're going to use these 2 panels. You've got your substance description before and the after description to describe the different states. Use the pencil icon up in the top left-hand corner or right-hand corner to edit each of the substances. You'll select the phase of the molecules and the appearance to describe before it melts, and so the phase change, the molecules, and the appearance for the before it melts, and then you'll do the after it melts. So remember to check the phase section and the molecules and the appearance as well. Your completed model should show how the phase change affects the molecule's movement. So that's the end of lesson 1.5. You should go back to Canvas. You should have been watching this video from Canvas. So go back to Canvas and see what your should do's and your aspire to do's are for today.